during mathematics 4. The last class we discussed some ideas of transverse vibration of stretched elastic string, and I got idea after 5 minutes of finishing that class, and that we have to include to identify one more constant b. No, one more constant b. We have to include the velocity, initial velocity of the string, and we have to include the initial velocity of the elastic string here. We see that there are two ways we can proceed here. The yesterday's problem, it is the initial position. Initial position. In the initially, the two ends are tightly fixed here. Not only initially, always, all the time here. The two ends are tightly fixed here. Therefore, we have to include these two conditions here. At x equal to 0, there is no displacement, 0. Therefore, similarly, at x equal to L, there is no displacement, that is equal to 0. And then initially, it is released from the position here. Initially, it is at the position. I will change it as this is 3x into x minus L, L minus x here. Not only this one here. 3x into L minus x, 3x into L minus x. Px into L. It is initially in a position. Initially means time t equal to 0 in a position and so on. From this position, the string is released here. Initially, the string may be in any form. Two ends are tightly, initially it may be in any position, but these two ends are tightly fixed. X equal to 0 and x equal to L, these two ends are tightly. Initially, it may be in some position here, 3x into this equation form, 3x into L minus x here. And it is released here. It is released, then it get vibrated vertically. It get vibrated vertically here. In that case, they are asking what will be the displacement of the string y at any time t at any distance x from the end x equal to 0. So at time t equal to 0, initially in the position 3x into L minus x form, 3x into L minus x form here, that we can represent. And also one more thing we have to include here. What is that here? Initially, at time t equal to 0, like at time t equal to 0, there is no, for the movement of the string, we are not applying any external force here. We are not going to apply any external force. It is some position and released here. We are not going to apply any external force means at initial time t equal to 0, and there is no velocity here, velocity of the string. And there is no movement here. That is t equal to 0, it will be 0. The velocity of the string, at time t equal to 0 is equal to 0. Therefore, velocity, y is the displacement. The velocity calculated by dou I by dou t. At x equal to 0. Okay. That we have to include here. Therefore, we have to include one more condition. Third one, dou I by dou t. At x is equal to 0. Dou I by dou t at x is equal to 0. Third one, we have to apply dou I by dou t at t is equal to 0. Initial time velocity here, that is equal to 0 for 0 less than x less than L. It is the initial velocity of this string. Here initial position, time t equal to 0, what will be the position of the string? This is initial position of the string. Two ends are tightly to two ends. Displacement is always 0. Displacement, because it is tightly stretched here. Two ends, displacement is 0. Displacement is 0. Therefore, because tightly stretched. For these four conditions, these two are combined conditions, and these three conditions we have to include. At some problem, sometimes initially it is in the rest position. Sometimes the string initially in the rest position, equilibrium position, rest position, and then by applying some external force, it get vibrated here. And that way, and that time, that the initial position of the string, x equal to 0 equal to 0. Suppose the question will be given like that. Here, suppose it is in the equilibrium position, means y x comma 0. Instead of this position, it is in the rest position here, 0. And then in that case, a velocity is applied at t equal to 0. A velocity, external force means a velocity is applied at t equal to 0, means you have to consider dou I by dou t at x comma 0 equal to some function of x. Some function of x. Some function of x will be given here. It will be interchanged here. Sometimes in the rest position means here 0, and that time no velocity, at that time velocity will be given as a function of x. Suppose initially in some position released and get vibrated, means it will be a function of x, and that time velocity is 0 here. Velocity is 0, not going to apply any external force at time t equal to 0. These two are different conditions you have to remember here. Remember here. That is the idea. Yes, yes, okay. Now, as usual, we are applying that Fourier sine transform here. Yes, we are applying Fourier sine transform. And we have 0 comma t minus 1 power n OL comma t. Already we discussed yesterday here. And then we take fs of y equal to y bar. Then we are getting apply these initial condition y of 0, t is 0, and y of lt equal to 0 here. Therefore, we can get this one. I am taking lambda equal to everything in terms of square here. Lambda is n pi a by L. And then obviously you are getting a second order ODE. Second order ODE here. After getting a second order ODE, second order ODE, you can solve this second order ODE with the help of auxiliary equation or getting the roots here. Imagine roots always you can get. And then solution will be in terms of, we also imaginary roots here, e power alpha x, c1 cos beta x plus c2 sin beta x in that manner. But alpha is 0 here. Therefore, you can write, instead of c1 c2, I am using ab here, a cos lambda t and so on. Okay, a cos lambda t and so on. The result is function of n comma t here, y bar n comma t. Therefore, lambda you can replace by n in terms of n here, n pi a by L, n pi a t by L here, and n pi a t by L. Yes, this is the idea. Now you have to identify these two constants, constants a and b, a and b. Then after that you have to take inverse Fourier sine transform, inverse Fourier sine transform. That is the thing you have to follow. But in order to identify the constants a and b, we can apply these two initial conditions here, the second one and the third one, second one, third one. When apply second one here, y bar of n comma 0, to apply second one, for initially put t is equal to 0 here. Here in this equation number 2, put t is equal to 0, then you can get y bar of n comma 0, sin 0, 0, you can get cos 0, 1, therefore you can get a here. A. Even put t is equal to 0 in the above equation. Put t is equal to 0 in the above equation. Put t is equal to 0 in the above equation, you can get y bar of n comma 0 equal to a here. To find a, consider the third initial condition, or second initial condition. Consider the second initial condition, that is y of x comma 0. Y of x comma 0 is equal to 3x into L minus x for 0 less than x less than L. 0 less than x less than L. 0 less than x less than L. Third, second initial condition, 3x into L minus x, 0 less than x less than L. Okay. Then apply Fourier sine transform, the same transform, Fourier sine transform for the above function. Then what you can get here, Fourier sine transform of y of x comma 0. Fourier sine transform of y x comma 0. Finite sine transform, therefore it will be 0 to L. y of x comma 0 sin n by x by L. Sin n by x by L dx. Sin n by x by L dx. Now y of x comma 0 equal to 3x into L minus x. We are going to identify Fourier sine transform y of x comma 0. Sine transform means y bar of x comma 0. Y bar of x comma 0. Sine transform means y bar of x comma 0 means it will be after transformation, it will be n comma 0, n comma 0, and 0 to L, 3x into L minus x sin n by x by L, sin n by x by L dx. I can write it as 3lx minus 3x square, 3lx minus 3x square into sin n by x by L. Sin n by x by L, sorry. It will be 3x into L minus x, therefore 3xl minus 3x square. 3xl minus 3x square sin n by x by L dx. Right. Okay. Then apply Bernoulli's formula as usual technique here. Apply Bernoulli's formula here. It will be u 3lx minus 3x square, u as it is here, and v1 is minus cos n by x by L, minus cos n by x by L, and whole divided by n pi by L, minus differentiation of this one, it will be 3L minus 6x, 3L minus 6x. Integration of this one, minus already present, therefore sin n by x by L, sin n by x by L whole divided by n square pi square by L square. One more n pi by L. And then formula plus, plus minus plus. Differentiation of this one again, it will be first factor. Differentiation of first factor will be minus 6. Minus 6. Then integration of this factor, sin integration is minus, already a minus is present, therefore it will be cos n by x by L, cos n by x by L, cos n by x by L, and then n cube pi cube by L cube, n cube pi cube by L cube. And then formula minus, differentiation of this one 0, or it will be 0 to L, or limit is 0 to L. As I will take we are going to apply the limits for x, take the constants outside here, without x terms outside. Here minus L pi n pi, minus L pi n pi, and then 3lx minus vx square into cos n by x by L, 0 to L. Here minus minus plus 3L minus 6x, and the L square by n cube pi cube. L square minus minus plus L square by n square pi square, L square by 3L minus 6x, 3L minus 6x into sin n by x by L, with the limit 0 to L, 0 to L. And then here L cube by n cube pi cube with minus sign outside, the minus sign outside, minus L cube by n cube pi cube, minus 6 also outside here, cos n by x by 6, cos n by x by 0 to L. When apply L here, it will be 3L square, 3L square. Here is also 3L square, 0. And when applying 0 here for x, 0 minus 0, 0 minus 0, that is also 0 here. 0. L square by n square pi square. Then apply L, L get cancelled here, sin n pi 0. Similarly, when apply 0, sin 0 is also 0. Then minus 6L cube by n cube pi cube. When apply L here, L get cancelled, cos n pi is minus 1 whole power n. and cos 0 is 1. Cos 0 is 1. Therefore, your answer will be 6L cube by n cube pi cube. 6L cube by n cube pi cube. 1 minus, I will multiply by minus 1 minus minus 1 whole power n. What is this? This is u bar of n comma 0. This is u bar of n comma, y bar of n comma 0. This is y bar of n comma 0. So y bar of n comma 0. Y bar of n comma 0. Already you identified y bar of n comma 0 equal to a. But already y bar of n comma 0 equal to a implies a equal to 6L cube by n cube pi cube 1 minus minus 1 whole power a equal to 6L cube by n cube pi cube 1 minus minus 1 whole power and j is 4. Okay. Now you have to identify b further. To identify b. This page over. Is this page over? Yes, to find b, consider the third initial condition. Third initial condition. Consider the third initial condition. Third initial condition. What will be third initial condition? That is y bar of dy by dy bar by dt. D by dt of y of 0 comma t x comma 0 at initial time. Initial time x comma 0, that is initial velocity. Initial velocity. Initial velocity d by dt of y x comma 0 equal to 0. D by dt of dou y by, because two variables are present, dou y by dt of x comma 0 equal to 0. And where b is present here? Yes, this is y bar of n comma t. From this you can find b here. From this you can find, because two variables are present, it is dou by dou. Dou by velocity. Y of x comma 0 equal to 0. Now take Fourier transform, apply same transform, Fourier sine transform for the above. What you can get here, it is dou by dou t. If you take Fourier sine transform of dou by dou y by dou t of x comma 0, right side is 0, therefore the same transform fs of 0 is also 0 again. How can you write this one here? D by dt of Fourier sine transform of y of x comma 0. Y of x comma 0 equal to 0. Outside of integration, it will be d by dt. For d by dt of Fourier sine transform will be y bar. After transformation, it is n, but already t is 0 here equal to 0. That is, what do you have here? dy bar by dt. Dy bar by dt of n comma 0 equal to 0 here. Dy bar by dt of n comma 0 equal to 0 here. 0. This is one condition. One condition here. You take it as any equation 3% here. No. You put it as 3. Now take because of this condition. Because of this condition, you take Fourier sine transform of dou I by dou t. This condition, initial velocity here. Get d by dt. Take it outside of integration to be d by dt. Fs of y of x comma 0 and d by dt of y bar of n comma 0. Then we can get d by dt of y bar of n comma 0. That form we can get. For this relation, you are getting. You can use now. You can use this idea for getting b. For getting b. But by equation number 2, equation 2, what do we have here? Y bar of n comma t. Y bar of n comma t. Y bar of n comma t. A cos n by a t by l plus b sin n by a t by l. Y bar of n comma t is equal to a cos n by a t by l plus b sin n by a t by l. B sin n by a t by l. B sin n by a t by l. Now, if you want to use this idea here, we need y bar of n comma t, y bar of n comma t, then differentiate with respect to t, then y dy bar by dt of n comma t, then after that put t equal to 0. After that put t equal to 0. Now differentiate this one with respect to t. Differentiate this one with respect to t here. What you can get? Minus a sine n pi a t by l into n pi a by l. N pi a by l plus here b cos n pi a t by l. N by a t by l into n pi a by, after differentiation we are getting. But we are need of 0. T equal to 0 here. Put dy bar by dt of n comma 0. Put t is equal to 0. Put t is equal to 0 here. Put t equal to 0 both sides here. And what you can get here? Sin 0 0. When putting 0, sin 0 0 here. Cos 0 1. Cos 0 1. Therefore, you can get b n pi a by l. B n pi a by l. This is okay. For what you are getting here, you see that dy bar by dt of n comma 0 equal to 0. This is fourth one. This is fourth one we are getting here. So we compare equation 3 and 4. Compare 3 and 4. Both are same. Compare 3 and 4 implies b n pi a by l equal to 0 implies b only 0. B only, because this is number and pi value here. A is tension by mass. There is also a constant. L length of the string, it is also a constant here. Therefore, everything is constant. But therefore, only possibility product of these two numbers 0 means only thing is that b equal to 0. B equal to 0. Remaining things are constants here. Therefore, non-zero values here. Or b equal to 0. Already by equation number 3, this is 0. This is 0. Now equation number 4, this is b n pi a by l. Therefore, we are getting b equal to 0. Therefore, this is the part of solution we are identifying here. Y bar of n comma t is equal to a cos n by 80 by b sin n by 80 by b, you are getting 0. A already you are getting 6l cube by n cube by q 1 minus minus 1 all power n. Therefore, substitute these two values in equation number 2. I'll have to understand it. Therefore, in order to identify b, are applying that initial velocity idea. Okay, right. Therefore, substitute a equal to 6l cube by n cube pi cube 1 minus minus 1 whole power n, and b equal to 0 in equation number 2. That is y bar of n comma t. Y bar of n comma t is equal to a cos n pi a t by l 6l cube by n cube pi cube minus 1 whole power n. A cos n pi a t by l n pi a t by l. B is 0. B is 0. That will be the idea. I can get that. Therefore, we can get 0. This is B 0. Therefore, we are getting y bar n comma t is equal to like this. Now take Fourier sine transform for inverse Fourier. Therefore, by inverse Fourier sine transform. Inverse Fourier sine transform. We have inverse finite Fourier sine transform. Finite Fourier, and we have what we have y of x comma t can be written as 2 by L, 2 by L summation n equal to 1 to infinity y bar of n comma t sine n by x by yes, sine n by x by 2 by L summation n equal to 1 to infinity y bar of n comma t is here 6L cube by n cube by pi cube 1 minus minus 1 whole power n into cos n pi at by L. This is y bar of n comma t into sin n by x by L into sin n by x by. This will be your solution. Okay. All of you understand it. In order to identify two constants A and B, initial position and initial velocity, two things you have to consider. Suppose sometimes some problems initial position given as equilibrium position means that is zero. That is zero. In that case, velocity is a function of x. Suppose initial position is function of x. It is in some position and then released to get vibrated. And in that case, initial velocity is zero. We are not going to apply any external force here. Therefore, it will get vibrated from its position here. Therefore, initial velocity is zero. Upon that manner, we have to think that. Right. Does all of you understand this idea? Okay. Now take another one where initial velocity is non-zero. Initial velocity is non-zero. Right. A tightly stretched string. A tightly stretched string with the fixed endpoints. With the fixed endpoints. With fixed endpoints. X equal to 0. X equal to 0 and x equal to L is initially at rest in its equilibrium position. Is initially at rest in its equilibrium position. If it is set vibrating by giving each point a velocity L minus x, a velocity L minus x, find the displacement of the string at any point. Find the displacement of the string at any point and at any time t. And at any time Okay, solution. Based on the given condition, we have the following. Based on the given condition, we have the following equation and boundary conditions. Boundary conditions. Based on the given condition, we have the following equation and boundary condition. Right. Equation, displacement equation is, what is the displacement equation? So please tell. Partial differential equation. What is the equation? Is my voice audible? All of you present here or not? What will be the equation? PDE. Ashwath? Ashwath, are you here?
Sir,
What will be the equation of the displacement?
rho square I by dot t square is equal to a
Uh,
square rho square I by dot x square.
Why you are not giving the answers? Some people are not giving the answers today. Dou square y by dou t square equal to a square and dou square y by dou x square. Then you have to write boundary conditions. Boundary conditions. What are the boundary conditions? A tightly stretched string with fixed endpoints. With fixed endpoints. X equal to 0, x equal to L. Fixed endpoints. Then what about your boundary condition for this statement? Fixed endpoints. Kalyani. Kalyani is here.
Yes, sir.
Fixed endpoints for boundary condition. X equal to 0.
Y of 0 comma t is equal to y of l comma t is equal to 0.
Yes, very good. Y of 0 comma t 0 and y of l comma t equal to 0. For t greater than or equal to, these two are fixed endpoints because ends are fixed. Ends are okay. Subdivision number 2 is initially, that string is initially at rest in its equilibrium position. Initially at rest in its equilibrium position. It is said vibrating by giving each point a velocity. The velocity is a non-zero. A velocity is non-zero here. So initially at rest in its equilibrium position. Therefore, can you give the initial position of the string? Initial position of the string means what about y of? Y of? Can anyone give the answer? Initial position. At initial means that t equal to 0. Initial time means t equal to 0. At t equal to 0, and then what about remaining part here? Y of?
X comma
X
0.
comma 0.
Yes, very good. Y of x comma 0. Initially in at rest in its equilibrium position. Rest means what about your answer?
0.
0. There's no displacement here. For here x is the variable here. What about the range of x here? L. L. Length of the string is L here. X equal to 0 to x equal to L. And then third one, By giving it set vibrated, by giving each point a velocity L minus x. By giving each point a velocity L minus x here. Therefore, velocity means how can you represent initial velocity here? The rest question you are going to give a force of velocity L minus x at each point here, 0 to L, each point. Therefore, that velocity, how can you represent here?
Dou y by dou t
Dou I by dou t of,
at x comma 0
yes, very good. X
is
comma
equal to
0.
L minus x.
Yes, very good. L minus x. It is also 0 less than x less than L. These are the three conditions. 1, 2, and then 3. Because of this condition is given, you have to apply always Fourier sine transform. Fourier sine transform. Because of initial condition 1, we can apply, this is initial rest position. Initially rest, initial velocity. We can apply finite Fourier sine transform on 1. That is fs of dou square y by dou t square equal to a square into fs of dou square y by dou x square. Dou x square. This is d square by dt square of Fourier sine transform of y. And this is n pi by L because of sine transform, n pi by L. Y of 0 comma t minus 1 n square pi square by L square fs of y of 0 comma t minus 1 whole power n y of L comma t, L comma t minus n square pi square by L square Fourier sine transform of y. Apply initial condition 0, 0 here, 0, 0. Apply 1 and let fs of y equal to y bar. That is Fourier sine transform of y of x comma t equal to y bar of n comma t. That is implicit meaning. Implies d square y bar by dt square. D square y bar by dt square, left side is y bar. 0, 0 minus n square pi square by L square into y bar. Pi square a square by L square y bar. For our convenience, take it as lambda about d square dt square plus lambda square y bar equal to 0, where lambda equal to n pi a by auxiliary equation is d square, m square plus lambda square equal to 0 plus or minus lambda I, plus or minus lambda implies y bar of n comma t, y bar of n comma t equal to a cos lambda t plus b sine lambda, because this equation contains only t. This equation, this PD, this OD contains only t. You can write in terms of t, but already lambda is n, and it depends on n. Or you can write a cos n pi at by L plus b sin n pi at by L. This is y bar of. Okay. Now your work is that you have to find get A and B. Can you give the answer for A and B? Can you give the answer for A and B? Applying Fourier sine transform for this one and this one. Put t is equal to 0, y bar of n comma 0, sine 0, 0. A you can get. To find A, apply f of st on subdivision number 2. Similarly, to find B, apply f of st on subdivision number 3. And put t is equal to 0 in 2. Put t is equal to 0 in derivative dy bar by dt of n comma from 2 and put t is equal to 0 in dy by dt. Can you proceed further? All of you try and give the answer for A. What is A? What is B? What is A? What is B? What is A? What is B? Apply finite Fourier sine transform in 2. This number 2. What is the value of A? A is A. Zero. Yes, A 0. Very good. A 0. And then get B value similarly. Value of A equal to 0. Similar to find B, apply finite Fourier sine transform on 3, subdivision number 3. For getting B value, you have to take the finite Fourier sine transform on L minus X dou I by dou T. But left side is dou I by dou Y by dou T of X comma 0. Right, left side, after taking Fourier transform, it becomes dy by dt, dy bar by dt of n comma 0, left side. But right side is obviously we are going to use 0 to L minus X sin n by X by L, sin n by X by L. Yes. We can get the result will be dy bar by dt of n comma 0. What about this integral value? L minus X sin n by X by L dx.
Sir, L square by n pi.
L square by n pi, yeah, very good. Anybody have a different answer? No. Okay. Then now from equation number 2, we differentiate this one, dy by dt of y bar n comma t, d by dt of y bar n comma, differentiate with respect to t, and then after that put t equal to 0. After that you put t equal to 0, then you can get the same equation, left side equation, dy bar by dt of n comma 2. Therefore, our answer for B is, what about B? Oh. So integral value is this one, L cube by minus 1 whole power n, L cube by n square pi square. Remaining people, anybody have a different answer? L square by n pi or this one, L cube minus 1 whole power n square pi square. With the A, yeah. This is B. Anybody have a different answer? You are getting whether you are getting L square A equal to 0, that's okay. Integration of this one will be L minus X minus cos n by X by L by n pi by L minus 1. Differentiation of this one is minus 1. It will be sin n by X minus sin n by X by L by n square by square by L square. Limit is 0 to L, other part is 0. Or minus L pi n pi, minus L pi n pi. When applying L here, L minus L 0. When applying 0 here, L. When applying L here, x get cancel. Cos n pi is minus 1 whole power n. Minus 1 whole power n. Here both are 0. Sin 0, 0. L gets 0. It is 0. So your answer for d y bar by dt of n comma 0. Dy bar by dt n comma 0 will be minus minus plus here, L square by n pi. L square by n pi into minus 1 whole power n. When apply L here, L with the cos n pi is minus 1 whole power n. Right. For L square by n pi with a minus 1 whole power n. Not only L square by n pi. But B differentiate this one and differentiate equation 2. Differentiate equation 2. We are getting B and T is equal to 0. Differentiate with respect to T and put the T is equal to 0 finally. As like yesterday's idea, previous problem idea, we are getting B n pi A by L. B n pi A by, yes, as I think as per the answer is correct. B n pi A by L. That is, we equate these two, both are same here. We can get B is equal to L cube by B is equal to L cube by n square pi square A into minus 1 whole power A. Yes, very good. Yes, as well, the answer is correct. For D, L cube by minus L cube into minus 1 whole power n square pi square. Yes, as well, the answer is correct. Then you can take inverse finite Fourier sine concept. L cube by n square pi square A into minus 1 whole power. Yes, very good. This will be your answer. Okay. I will give one more problem for your exercise. A taut string of length 2L is fastened, fastened, fastened at both the ends. Fastened means tightly fixed, both the ends. Both the ends. The midpoint of the string is taken to a height. Midpoint of the string is taken to a height. Taken to a height B, and then released from, rest in that position. So find the displacement of the string. Find the displacement of the string. Wow. Here a taut string of, here there is no function of x equation is given, but you draw the figure based on that. A taut string of length 2L is fastened at both the ends fixed here. The midpoint of the string is taken to a height B. Well, this is a height B. This is a height B. Midpoint of the string is taken to a height B, and then it is fixed like that here. It is fixed like that. Fixed like that here. For this 0 to 2L, in the 0, 0, and then 0, 2L, 0, 2L, 0. Midpoint is here. It will be L, B. This is L. Midpoint is L. It's taken to a height B. Taken to a height. It is initially in this position. And then released from rest in that. From this position it is released. Then it get vibrated vertically. Therefore, there is no external force giving. Therefore, initial velocity is 0. This is initial position. For initial position, y of x, these two are tightly fixed here. 0, t 0, 2L, 0, 0. That is at 2L, t. That is also 0 here. Therefore, here here y of x comma 0, y of x comma 0, that will be given by equation of the line. Suppose this will be O A B, O A B. You can take it as the equation of straight line OA, and then this will be equation of line AB, AB for 0 less than x less than L, and for 0 L less than x less than 2L, L less than x less than 2L. In that manner we can consider it. In that manner we can consider it. Equation of line OA. How can you find equation of line OA? You can use line equation. Y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. O is 0 comma 0, that is x1 y1, and A is L comma B, this is x2 y2. L comma A is L comma. Similarly, equation of line AB. AB also same thing here. A is L comma B, and B is what? 2L comma 0. X1 y1, x2 y2. That matter. Then you are getting this is x comma 0. Initial velocity is 0. Therefore, it will be dou by dou t of y bar of x comma 0 0. Initial type is fixed here. 0 comma t 0. That is equal to 2L comma t 0. Is all of you try this problem in your leisure time and you can get the answers here. Right. As I have another class, I will see in the next class. Thank you. Thank you for attending. And one more thing, the Wednesday, you write the test in two manner here. One test is purely objective type here, multiple choice, MCQ type here. Another one is purely descriptive type here. Therefore, in the objective type, you can get the options here, but in the descriptive type, both in terms of Google Classroom, it means that I will the same Google form. Okay, you can upload your document in the Google form for descriptive type. You write and then attach your file. In that manner, you can write here. Therefore, for descriptive type, you study the application part of problems here. The application part of problem. For objective type, the previous types. About two tests here. Before application and after applications. Before application for objective type MCQ type questions here, and application parts are you can expect in the descriptive type. Wednesday you have to write the test. Okay. Yes. Maybe okay. Depends upon your time. Each 1 hour or 1.5 hours depends upon the condition. You can take it. Okay. Thank you.